Okay, so today we'll discuss a few problems regarding your midterm. Okay, so you can try to solve today also during this session, class session. Okay, okay. Can you write the problem? Okay, I can write the problem and we'll discuss. So we'll present. Say you try to solve it, right? Say if we consider, okay, problem number one. Say consider the following reaction. A to B and B to A reversible reaction. Let it constant K1 and it is K minus 1. Okay. And let both are first order. Consider the following reversible first order reaction. Okay. And equilibrium constant of the reaction, let it is about 10 to the power, say 6, right? Now the activation energy, suppose this is K1 with activation energy for the forward reaction E1 and the backward reaction let it be, sorry, for backward reaction let it be, say E prime. Why? So E1 and E1 prime, they are activation energy of forward and backward reactions respectively. Okay. 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 So E1 and E1 prime are activation energy of forward and backward reactions respectively. An equilibrium constant is given, right? And let the activation energy, that is E1 prime, be say 80 kilojoule per mole, say, or 80, okay, 80 kilocalorie per mole. Okay. Now, Arrhenius free exponential factor, suppose the Arrhenius pre-exponential factor associated with this, say, what is k minus 1, that is equal to, let it is a prime Arrhenius pre-exponential factor into e to the power minus e prime by RT, right? You know this formula, Arrhenius equation, right? This is Arrhenius equation that you know. So E1 prime, sorry, it is simply E1 and E prime. You drop this one. Okay, sorry, one should be dropped. Yes, yes. E1 and E1 prime. Okay, and this is the expression that is uh, backward rate constant, which is given by a prime into e to the power minus e prime by r. Right? This value is given. Equilibrium constant and e prime is given. Now you are asked to calculate. Oh, sorry. This pre-exponential factor, let it be given, say, a prime. That is, you can take, say, 10 to the power 10 second inverse. Okay. Now, question is, these are given. All these three parameters are, these are given data, given data. And you are asked to calculate the observed rate constant, calculate the observed rate constant at, say, temperature T equal to 20, sorry, at T, sorry, at T equal to 25 degree Celsius. Okay, provided 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 uh, the reaction occurs uh, starting with an initial concentration of A. Starting with an initial concentration of A. Right. Then what should be the observed rate constant? That is the question. Right. Now, what is the observed rate constant? How can you guess? Both the reactions are first order. Can you first identify what is the observed rate constants? Or try to solve yourself? Calculate the observed rate constant at T equal to 25 degree centigrade, provided the reaction occurred starting with an initial concentration of A. Whatever the initial concentration of A, just here only one reactant A and initiate the reaction. Okay, that's all. What should be the answer? So try to solve this. Hello. So try to solve this question. Say A to A to B. How will you proceed? You know equilibrium constant. What is that? Hello.
10 to power 6.
Can you listen me?
Yes,
So
sir.
we try to solve. So what is equilibrium constant? Solution. K equilibrium, that is equal to, it is given here.
10 to power 6.
Okay. K1 by K inverse 1, that is equal to, it is given. Whatever the value it is given is here, 10 to the power 6. Right? It is a dimensionless quantity, so we have put like this. Equilibrium constant. Okay. Now, if you write down this equation, say A to B and B to A, with constant K1 and K minus 1, then say what is the rate of forward reactions? Just I am writing like this. Can we write like this? That is dA. Okay, just you write like this. Okay. So what is dA dt? Because dA dt is produced in the reverse way. So it would be K minus 1 into concentration of B minus that of A decreases in the forward reaction, so that's a negative rate minus K1 A. Okay, both the reactions are phosphoryl, so I have written like this. Okay, now what is the concentration of, you have to express it in any terms. Say, what is B in the first order reaction? Can you write it in this form? What is B? product concentration equal to? Can you guess?
V naught into e to the
A
power,
naught, right? A naught into e to the power
so minus k1 t e to the power minus k1 t,
a zero into 1
1
minus
minus e to the
e
power
to the
minus
power minus k1t. Is it? Can we write like this? B equal to, there is a product concentration, right? A zero into 1 minus e to the power minus k1t, because at time t tends to infinity, so this term would vanish, and B converted to concentration of B stoichiometry ratio, since it is 1:1, it will be fully a zero. Okay, we can write like this. So you can put it here. Say k minus 1 a zero. Just I'm writing k a zero into 1, or better you can write like this, k1 a zero into 1 minus e to the power minus k1t. Okay, minus k1a. Okay, so this we can write k minus 1 a zero, just split it, minus k minus 1 a zero into e to the power minus k1t, and minus k1a, and a equal to, again you can write, uh, so yes, you can write what is k, what is a equal to, for forward reactions, fast forward reactions, so a equal to, we can write a zero into e to the power minus k1t. Okay, so we can write k minus 1 a zero, okay, minus k1 a zero into e to the power minus k1t, okay, minus k1 a zero into e to the power minus k1t. Okay, or you can simplify, instead of that, uh, instead of that, you can simply write, you can simply write dA dt, uh, that is equal to k minus 1 a zero minus k1a. Uh, okay, the problem is that it is k minus 1a, right? K minus 1 a zero into e to the power. So can we write like this? Instead of this, can we simplify? Just k minus 1 by k1 into, uh, okay, k1 a zero into this is equal to, you can write simply a, okay, and minus k1 a. So that this equation we can write minus k1 a zero and minus k1 plus k minus 1 a. Right. Now, what is this? What is the physical significance of this quantity? So, at the very beginning of the reaction, right? At the very beginning of the reaction, what we can say, this is a almost constant quantity, and at the very beginning of the reactions, this we can ignore. Basically, K minus K inverse A0, right? You see, what is K inverse A0? Basically, what does it mean? Say, if we consider equilibrium constant is very large, right? You see the magnitude. Equilibrium constant, that magnitude is very large. That means K minus 1 is much, much less compared to K1. So anyway, so we can ignore this term and then simplify like this: minus K1 plus K minus 1 A. And okay, if we observe the negative sign here, then we can write like this: minus dA dt equal to this, right? And this we can say, what is that? Can you guess? What is K1 plus K minus K inverse 1? That is the effective rate constant or
K equilibrium.
apparent,
Rate
or you can
constant.
say K apparent. That is better. This is the K apparent, right? Apparent rate constant. This is equal to K1 plus K minus 1. And in the question we asked that what is the observed rate constant. This is basically K observed, right? Better you say, same we can say K observed, because at the starting point this is equal to K1 plus K minus 1. This quantity you have to find out. Okay, so everything is given. I think you can do it yourself. Suppose first of all, what is the value of this? A prime into e to the power minus e prime by r3, right? A prime is given 10 to the power, what is that data? 10 to the power 10, okay? 10 to the power 10, A prime, second inverse, into e to the power, that is what about that value of 80 kilocalorie per mole, right? Okay, so 80 into 10 to the power 3 calorie. Then R is given, in calorie it is nearly 2, and temperature is 298 calorie, 25 degrees centigrade. So you can calculate, this is known to you. Now once you know this, then you can calculate the forward reaction rate constant from this equation. That is, it would be what? Equilibrium constant is given 10 to the power 6. Okay, so 10 to the power 6 times of K inverse backward rate constant. This is known. So put it here, right? It is known. So you can calculate K1. Now you can calculate also K, uh, that is observed rate constants, which is equal to that I have written K minus 1. So this you can calculate yourself. So this is the outline of the method. How will you proceed? And at this stage, you have any clarification, please let me know. Whether can we write or not? That is the question.
Sir, once again, if you can explain the last step, uh, approximation.
Yes, dA dt equal to this,
Yes.
because you are asked to calculate. First of all, you have to calculate K1, that is rate constant associated with forward reaction. So initially you have written overall accumulation dA dt equal to, this is clear, first one?
Yes,
This,
sir.
okay. Then we put what is product concentration in the first order. I have already discussed, you can see, you can
Yes,
check
sir.
it also. A0 into 1 minus e to the power minus K1t,
Yes, sir.
like that. Okay. So if you put it here, then what you can write?
Sir, I understood this part. The last one,
This one.
approximation
This
at,
one.
uh,
Yes, yes. This one. The last line. Or this one.
yes, sir, the last line, which how you have approximated, removed A naught term. Once again, if you can explain.
Okay. Is it all right? This.
Yes, sir. Yes, sir.
Okay, okay. Now the question is, say at the very beginning of the reactions, right? If you look at the equilibrium constant, its magnitude is 10 to the power 6, right? So that means K1 is much, much larger than K minus 1, right?
Yes,
Can
sir.
we write like this?
Yes,
So
sir.
naturally, this quantity, this quantity is significantly less. So that's why we have ignored that. That is K minus 1 is very small.
Okay,
Whatever
sir.
amount you have taken, so we can ignore this term. That's why, nothing else. Okay. So this is the justification, nothing else. So that's why we dropped this term. Right?
Yes, sir.
And
Understood.
yes, yes, yes. And this is the apparent rate constants. That's why it is apparent. Means approximate or whatever you observe, this is you can get. Because experimentally you cannot get the exact value. Right? So that's why theoretically we can calculate, we observe like this. This is clear. I think Arrhenius equation we use, right? Simple formula K equal to A into e to the power minus E by RT. Arrhenius equation, you know that I have used. Okay. So I think you have understood this problem. And the unit constant is very important. Here it is kilocalorie, I have converted it to calorie. So it is, I think R value is almost 1.98 around 2 calorie per mole. But if it is given, say, in joule, right? Suppose if E1 is given in joule, then R should be used as, what should be the value of R one can use?
8.314.
Yes, that is to remember. Joule per mole per Kelvin. Okay, this is joule per mole per Kelvin. This is unit. So in that case, you have to adjust the unit like this. Okay. So now I'll give you another problem, and that I think you will be able to solve also. Okay. This is problem 2. Problem number 2. The question is that consider the following reactions. So A to B and B to C that we have considered earlier, right? With say rate constants, say K1, K2, like that. And at t equal to 0, initially concentration of B equal to concentration of C equal to 0. Right. And at any time, as you know, total concentration of A 0 must be equal to what? Concentration of A, B, and C at any time. Conservation of the mass that you know. The total initial concentration of A at any time must be equal to this because of the 1:1:1 situation. Now the question is find the time dependence of product concentration, sorry, here C. Find the time dependence of C using the steady state approximation. Now you try to solve yourself. Very simple. This is a consecutive reaction, you know, two-step reaction, A to B and B to C. Let both are first order. And at time t equal to 0, we can write this. This you know. Now find the time dependence of C using the steady state approximation. What should be the answer? You try to solve yourself. That's 10 minutes, within 10 minutes. Within 10 minutes, you try to solve this. Find the time dependence of C using the steady state approximation. What should be the answer? First of all, you have to identify which one is the intermediate. I think it is clear to you in the steady state concept. right?
Sir, K1 by K2 into A naught e to the power minus K1 by T.
Concentration of C, that would be equal to, what is the answer?
K1 by K2.
Answer would be somewhat like this. I think that we deduce
1 minus e to the power minus k1t.
K1T, right? This would be the answer. Because this is a simplified expression, if the first step is first and second is slow, that we have considered it, if you could remember, and then the reaction reduces to the first order with respect to that which is the slowest one, because the rate constant appears here K1. That means this second step is much slower. Sorry, it indicates that A to B is slower step compared to B to C, which is faster. In our previous model, if you compare this expression. And actually, this is the expression I think you will get if you cautiously do the calculation. You will get this expression. Because things are not so complicated. Things are very straightforward. Why the things are not so complicated? Because uh, you know the rate equations, that is, what is the dc dt? Can you write is equal to dc dt equal to what I can write? What is dc dt? It will be K2
into B.
B, right. But what about dB dt at the steady state? Steady state. And this can we, how we can write it? Because it is produced in the first step and it is subsequently consumed in the second step. Sorry. Yes, 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 yes. Yes, it is produced in the first step and subsequently consumed in the second step. So you can write like this, and this must be equal to 0, right? And from that you can write the intermediate concentration. Here B is the intermediate species, intermediate. So can we write B equal to K1 by K2 concentration of A? Okay. Now you put this expression of B here. Then what you can write? dc dt would be equal to K2 into B, that is equal to K1 into A. Okay. And this we can write, this is equal to, since the reaction is first order, K1 K0 into to the power minus K1T. Okay. And now you are asked to calculate concentration of C dependent substance. So you have to integrate it. integrate it. And what is the result? Now I think you can do it. dc dt equal to this, right? So I think if we integrate it, that is k1 a0 into e to the power minus k1t dt. If you integrate, say, close the interval 0 to t at an arbitrary time t, and it should be at the very beginning. What is the concentration? 0.
0.
And now let the concentration at any time be c. Then naturally c would be equal to what? A1 A0. This is a constant quantity, so you can take it outside of this integral into e to the power minus k1 t dt. Is it all right? Hello? Can you hear
Yes,
me?
sir.
Okay.
Yes, sir.
So then you can write A0, and if you integrate, it would be to the power minus k1t by minus k1, right? The limit would be 0 to t. So it would be, I think, product concentration C equal to K1 K0. Okay, K1 is constant. I can take the minus sign here. So it would be to the power minus K1t minus 0 means 1. Okay, and so if you observe the negative sign, so we can write a 0 into 1 minus e to the power minus k1t. Okay, so this is the answer. Okay, so you see, if you use the steady state approximation to this consecutive reaction, the derivation is very short, and ultimately, of course, the expressions that you get, it is not exact, but it is approximated one, of course, because if you could remember that, okay, we obtained these expressions. What is that? Yes, we obtained, yes, at the steady state. Okay, ultimately, what we got, yes, this is the expressions when, where did it just, yes, this is the answer, right? Now, this is nothing but in a rigorous derivation, you see, if we approximate like that, case 1, that is slower, if we make consider the first step is slower compared to the second step, then only we can get this expression, right? And if we consider the reverse one, that is B to C is slower compared to A to B, which is faster, then in that case, C would be equal to what? C would be equal to A0 into, I think it is not so straightforward. Some expressions may be there, but somewhat like that, A0 into 1 minus e to the power minus A to T, like that. Under the approximation that A to B is faster, whereas B to C, which is slower. That is the model that we discussed earlier. Hmm. This is in our earlier discussion. Follow our earlier discussion. Okay, so you can do that. But this part, using steady state concept, you get straightforward this answer. And how to get it? Very simple derivation. Okay. Do you have any confusion? Hello.
No, sir.
So
No,
I'll
sir.
advise you to go through the details that we discussed in my classes regarding reaction mechanism particularly, and the reactions that we have already done. Now, what is the hot topic that I covered in the last class? Can you tell me? What is the topic that we covered in the last class?
Chain reaction.
Can you
Chain
remember?
reaction.
Chain reaction, have you completed or just started? Can you remember? What is the chain reaction you have discussed? Hydrogen bromine reaction, have you completed?
Yes,
Hello?
sir.
Okay, okay.
Yes, sir.
So today I'll not discuss anymore. So if you have any question regarding the midterm exam, you may raise any question if you like. Any question? I think everything is clear to you, and hopefully I expect that you'll do better in your midterm exam. Okay. Okay.
Thank you, sir.
If you have no question, then I can stop here. Okay.
Sir, I have a doubt.
Yes, yes. Regarding what?
Sir, in exam, sir, if some question comes, so we can directly put the formula and take the answer, or we have to derive the formula also.
No, 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 no. Suppose if numerical problem is there, then if you can remember, you write down the formula
Okay,
and
sir.
write down the corresponding terms. Suppose if you write the Arrhenius equation, K equal to A into e to the power minus E by RT. What are the terms? What is A? What is K? What is T? What is R? What is E? So all these terms you have to write clearly mention. And if some values are given to those constants, you have to write it explicitly. And also you have to maintain the dimension properly. Otherwise, you will not get marks. That is unit mismatch. If there is some unit error in your putting the values in the appropriate unit, then you get 0 marks for numerical problem, right?
Okay,
So
sir.
you need exact answer with proper unit. That is very important. That's why
Okay,
I already discussed regarding this factor. That is, what should be the value of R? You have to remember. Okay.
okay, sir.
But for derivation part, if you need the question as we discussed today, the second one it is merely derivation. So you have to just derive it. Otherwise, how will I get the answer? Right.
Yes, sir.
So depending on the question, I think you'll be able to solve those questions. Those who attended my all classes, they will. I'm sure they'll be able to answer full parts, right, with 100% marks. Those who attended my classes till now. But those who are not attending the classes, I have no assurance. I cannot give them any assurance regarding their performance. Okay.
Sir,
Yes.
sir, how many marks will be from physical chemistry?
Maybe 10 because total marks I think it will be 30 in the midterm exam and duration would be maybe I don't know maybe 1 hour like that or
No, sir,
30
45 minutes we have.
45 minutes.
45 minutes, right, right.
So will there be step marking?
No step marking because in the derivation part if I find that some minor mistake then we can consider. Otherwise if gross mistake is there then you will not get good marks. Right. So don't be worried. Those again
Okay,
I
sir.
am assuring those who are uh, regular in my class attendance, they will surely do a better performance. Right. Otherwise, but the remaining other students who are not interested, right? And another thing, this is my advice, whatever the topic or the courses you are attending, you please attend it with interest. Means you should get interest and perform better. Marks is very important. and also for your future direction, that is very important. What you do, whatever you can do, right? Okay. So thank you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.